Assalamu alaikum students. We are going to discuss the remaining three questions of the same paper October 2019, paper 1-1. And now this time we are going to discuss question number 9. And as we can see that this question is relating to trigonometry. Now here you see that he's asking a curve for which dy by dx is equals to this passes through the point 2, 3. Find the equation of the curve, and we know for finding the equation of the curve we have to integrate it. So let's start integrating it. Y is equals to 5x minus 1 power 1 over 2 minus 2 and dx. So it's going to be 5x minus 1 power 1 over 2 plus 1 is going to be 3 over 2 divided by 3 over 2 and into derivative of this, which is going to be 5 and minus 2x and plus some constant of integration c. Let's do a little bit simplification. This is 5x minus 1 power 3 over 2 divided by 15 over 2 minus 2x plus c. So y is equals to 2 over 15 because this 2 will go up. 5x minus 1 power 3 over 2 minus 2x plus c. Now by placing the value of x equals to 2 and y equals to 3, we can find the value of c. Y equals to 3 and x is equals to 2. So 5 2s are 10 minus 1 is 9 minus 4 plus c. So we can use calculator over here for our convenience. This is 2 over 15. 9 power 3 over 2. It's going to be 27, I think. 27 minus 4 plus c. So for finding the value of c, we'll shift this and this to the other side. So it's going to be 3 plus 4 minus 27 times 2 is 54 divided by 15. So it's 7 minus 54 over 15. So the c is going to be 7 minus 54 over 15. And this gives us 17 over 5. So by placing this value of c over here in this place, we can find y is equals to 2 over 15, 5x minus 1 power 3 over 2 minus 2x plus 17 over 5. At the most, what we can do that multiply by 15, and you can just simplify a little bit more. That is 15y is equals to 2 into 5x minus 1 power 3 over 2 minus 30x and plus 51. So this is your solution for this. Now, if we go for the next part here, it says find the value of the second derivative. dy by dx was equals to us, okay, 5x minus 1 power half minus 2. So dy by dx was 5x minus 1 power half minus 2. So let's take its derivative once again. d2y over dx square. Half comes back, 5x minus 1 power half minus 1 into derivative of this is going to be 5 and minus 0. So it's going to be 5 over 2, 5x minus 1 power minus half. Or at the most, we can write it 2 and 5x minus 1 square. Now, let's go for the next part. Find the coordinates of the stationary point on the curve and find its nature as well. Coordinates of the stationary point, so we have to place dy by dx equals to 0. And dy by dx was 5x minus 1 power half minus 2. And let us place it equals to 0 for the stationary point. So 5x minus 1 power half is equals to 2. By taking square, 5x minus 1 is equals to 4. So 5x is equals to 5. So x is equals to 1. Now for finding the stationary value, we have found it, determine its nature, coordinates of the stationary point on the curve. So let's place this value of x equals to 1 in the original curve to find the value of y. And for finding the nature, we have d2y over dx square we have found earlier, and that was 5 over 2 square root 5x minus 1. Now if you place the value of x equals to 1 in this is for sure that it's going to be a positive answer, which is 5 over 4 greater than 0. So it is a minimum value. So this was your question number 9. Let's go further to question number 10. And this is regarding vectors. He is asking, show that AB is perpendicular to DC. And as we know, for the perpendicular vectors, we have to show the dot product is equals to 0. Let's find AB first, which can be found from OB minus OA. So 2 plus 1 is going to be 3, minus 3 is going to be minus 6, and 5 plus 4 is going to be 9. Similarly, if we are looking for BC, so it's OC minus OB. So 4 plus 2 is going to be 6, and minus 2 and plus 3 is going to be 1, and 5 minus 5 is going to be 0. Now let's find the dot product of AB and BC. If it is equals to 0, so then the vectors are perpendicular. So 3 times, sorry, this is 4 minus 2 is going to be 2 over here. So it is 3 times 2 is 6, minus 6 times 1 is minus 6, and 9 times 0 is 0. So it's going to be 0 over here. So it means AB is perpendicular to BC. Let's go further, and it says, show that ABCDs are trapezium. Trapezium means if we are able to prove that AB is parallel to DC, then it is a trapezium. If AB is parallel to DC, let's find AB. AB we have found already that it was 3, minus 6 and 9. 3, minus 6 and 9 was AB, and DC AB is 3, minus 6 and 9. And DC, let's find the value of DC as well. k, d minus c. So 2 minus 4 is minus 2 plus 4 and minus 6. Minus 2 plus 4 and minus 6. Minus 2 plus 4 and minus 6. Now, we know when two lines are parallel, AB equals to K times DC. So 3 is equals to minus 2K. So K is going to be minus 3 over 2. Let's check from the other ones. Minus 6 is equals to 4K. So this is also 3 over 2. And 9 is equals to minus 6K, which is also 3 over 2. So AB is parallel to DC. So it shows that it is a parallelogram. Trapezium. Now, if we are going for the next part, and the next part says, calculate the area of the ABCD. Since it's a trapezium, so parallel sides, half sum of parallel sides into height. So we have some values. AB it is 3 minus 6 and plus 9. BC is going to be minus 2 plus 4 and minus 6. And the next one is BC. BC is 4 minus 2 is 2, 1 and 0. So we will be using the magnitude of a vector to find the length of these. So AB length is 3 square minus 6 square 9 square. And this gives us 9, 36 and 81. And this gives us 126 square. Now, the next one is DC. And this gives us 4, 16 and 36. And this is 56 square root. And the third one is BC, which is 4 plus 1 plus 0. And this is going to be 5 square root. So area is half sum of parallel sides, which are these two, 126 plus 56 and multiply by square root 5. And you simplify this to get the value. This gives us 20.91. Now let's go for the next part, next question, and the last question, that is, okay. Here it says express x square plus 4x plus 3 in the form this one. So first of all, let us express this in the completing square format. So we know that y is equals to a into x minus h square plus k, where h is equals to minus b over 2a and k is equals to f of h. So h is equals to minus b over 2a, it's going to be minus 2. And f of minus 2, it's going to be 4 minus 8 plus 3, which is minus 1. So the equation becomes y equals to 1 x plus 2 whole square minus 1. And hence for this, express x in terms of y. So if we are looking for x in terms of y, so it is y plus 1 square root minus 2 is equals to x. This is all about this part. And now the next one is there. And show all necessary working. Find the volume obtained when the shaded region is rotated through 360 degree about the y-axis. About the y-axis. So it's from minus 1 to 3. We have to integrate it. Minus 1 to 3. Volume of revolution is pi x squared dy. Minus 1 to 3. And we have the value of this we have found already. That was y is equals to x plus 2 whole square minus 1. So y plus 1 square root minus 2 is equals to x. So x square is equals to okay. Now when you will write it, here it is x square dy. So it gives us pi minus 1 to 3. And this is y plus 1 plus 4 minus 4 square root y plus 1 and dy is there. So let's integrate this now. Y square by 2 plus 5y minus 4 y plus 1 power 3 over 2 over 3 over 2, and the limits are from minus 1 to 3. Now pi as it is. Let's do a little bit more simplification. Y square by 2 plus 5y minus 8 by 3 y plus 1 3 over 2 and minus 1 to 3. So let's do a little bit more simplification here, which will help us by placing the value of 3 first over here. So when we place the value 3 here, what do we get? 5, 9 by 2 plus 15 minus 8 over 3 into 8 minus. Now when you place minus 1, so it's going to be 1 over 2 minus 5 minus 8 over 3. And since we place minus 1, so this whole factor will become 0. So it is pi. And let's use a little bit calculator here. 9 over 2 plus 15 minus 64 by 3 9 by 2 plus 15 minus fraction 64 divided by 3, and this gives us minus 11 by 6. And here what comes to us? 1 by 2 minus 5, and this is minus 9 by 2, which will make it plus 9 by 2. So 9 by 2 minus 11 by 6 gives us 8 by 3. So we are left with 8 pi by 3. This is the solution of this part. Now, let us find if we have any other part with us. No. So that's all for you at this paper. Paper 1-1, October, November 2019. Thank you so much.